Hello, this is Avdesh, and in this session, I'm going to take a topic Quebec normal form. As in my previous session, I have discussed about CNF, that is Chomsky normal form. In previous lecture, what I have discussed why there is a need of normal form in the grammar in context of grammar, and there are multiple type of standard format. Another format other than CNF is GNF, Quebec normal form. So, how could we identify whether a given contextual grammar is in GNF or not? One. Second, if it is not, then how could we convert the grammar? So, the format of the Quebec normal form is like this. Here, so uh, each and every production of the given contextual grammar should be in this format. Like left hand side have only one variable, and right hand side has starting from a terminal and then a series of variables. So in some mathematical notation, it is denoted like this. A produces A alpha, where A is the terminal, any terminal, and alpha is string of some non-variables, and alpha could be epsilon as well. So for a given grammar, if each and every production is in this particular format, then we would say that the given grammar is GNF. If it is not, then that given grammar is not in GNF. Now, if a given grammar is not in GNF, how could we convert it into GNF? So for that, uh, one component is required named as left recursion. So first we discuss what is left recursion and how could we remove that. And this is a component for GNF. So component for GNF in the sense, if a given contextual grammar is not in GNF, so in process of converting a contextual grammar into GNF, this is a requirement. This is a component which is required. So I'm going to discuss this thing first. So for left, what is left recursion in context of grammar? So if is something like this, A is equal to A alpha. Alpha is could be anything, any string of terminal and variable. It is alpha. So if in these two position in production, left hand side of single variable, and on the right hand side the first symbol, if these two symbols are same, if these two symbols are same, then we would say there is a left recursion. Why left recursion? First, there is a recursion because A is reduces to A plus something. Now, again, we would reduce this A with this the same production, and if we would create a tree of this derivation tree using this derivation, this could be like this: A alpha, again A alpha, again A alpha. So it would be continue till we would get the base case of A. So it would be like this. If it is so, then this would be, could write it like this. So if there is this type of format in any production, then we would say in our grammar there is a left recursion. And why we have to remove the left recursion? If there is a left recursion in our grammar, the parsing would take extra time in comparison to the grammar which don't have the left recursion. So for the sake of efficiency, we have to remove the left recursion. Now, what is the process of left recursion? We would see right now. So if this is a grammar and there is a left recursion, so in order to remove that left recursion, we would translate these production into these productions. Now, how this would be converted, let's discuss that first. This variable would be continuously derived on like uh, leftmost derivation sort of thing, like A produces again A alpha, then this A produces again A alpha, like this, what I draw it before. So there would be series of multiple A's. If I would say like if I'm using this production 5 times, then there would be like this 5 times alpha 1, then A. This would be like this. If I am using this production 5 times, this would be yield of using 5 times of this production. So instead of growing in this direction, what could we grow in this direction from right side? And for that, what would we do? We simply put a new variable in at these position, this position. So what would we do? We simply write down like this. Means instead of writing A goes to A alpha, we would write it like A produces alpha Z. Now here Z is a new variable. And again, now Z produces alpha Z. Alpha. And this is this production will intact, and this would be like A produces beta. Now this production would be converted to these set of productions, and these two are equivalent, but in this grammar there is a left recursion, and in this grammar there is no left recursion. So in this way we remove the left recursion. How there is no left recursion, it is clearly visible because there is no production in this grammar where left hand side and right hand side, the first symbol of right hand side is same symbol. Here A and here beta. And the first symbol of beta could not be A. Why? Because if it were, then this should be part of this region. So first symbol of beta could not be A. Here A goes to alpha, and alpha, the first symbol of alpha could not be A. And the same here, there is Z, and the first symbol of alpha could not be Z. So there is no left recursion. And now why these two are equivalent? Whatever we could produce from this grammar, the same could be produced by this grammar, and what we could not produce by this grammar, we could not produce the same here as well. So what could we produce here? We could produce here, and what we could not produce here, we could not produce here as well. So these two grammars are equivalent, and the difference between these two grammar are the left side of the grammar. This grammar is having left recursion, and this grammar do not having left recursion. In next lecture, I would tell about how could we convert a given context-free grammar into GNF.